Hello and welcome to course P20, which is the contact tip GD&T. Contact tip, geometrical dimensioning and tolerancing. I want to talk a little bit about contact tips and the importance of making sure the contact tips are the right ones for your job. Now, I'm almost exclusively talking to my automation friends here because we have a lot of special criteria for a contact tip, especially when it comes to location. I want to share with everybody the what I look at when I'm looking at one of these contact tips and what all this information ends up meaning to me. The orifice diameter turns into a bit of a challenge sometimes because there's different ways to achieve that orifice diameter. From the manufacturing perspective, they actually sometimes they drill them, sometimes they swage them, sometimes they spin them around a mandrel to try to get it. But the best quality contact tips you can get are ones that are literally drilled. Ultrasonics are an option too, but I understand that process is very slow at this point. So having a good, properly drilled contact tip that gives you a decent surface finish on the inside and making sure that they're in the center and on size is important. Tight tolerance, there's different tolerances along the way. Normal clearances are about 8 thou, but 5 thou is very common for automotive. Some companies like it even tighter than that. They will actually specify, I want 4 thousandths of clearance. Years ago, there was a bunch of discussion about this with General Motors, and they did an enormous study and found that the optimum place for clearances is about 6 thou. Most of the automotive version of a contact tip is about 5 thou of an inch right now. The other challenge is concentricity. Is that hole in the middle? Now there's a picture of a contact tip there, and dimensionally, I've actually found the center. Now the picture doesn't do it much justice, but that contact tip hole, the orifice in the middle, if you look at it carefully, it's way up and off to one side. Now this should be alarming to anybody who's been around contact tips and knows the effectiveness and the result of having contact tips that would have an orifice that's off center. This eccentric condition means that every time I change a contact tip, it could potentially change where my wired location is. And nobody wants to be touching up their robots every time you change a contact tip. So I developed a little bit of a process utilizing this, and you can see my kit there. This is a pin set kit. It's made specifically to find out what the size is of the contact tip and what the clearance is. So I have sets that I lend to companies. If you want to examine your sets, you can let us know, even if we're supplying it to you, because I've actually made sure that ours are falling within a certain tolerance and audit that often. So just in case you want to see how far that might run off, I've actually included this procedure where you can actually test it. Literally, if you follow this procedure, you would put one of those pins inside this contact tip, inside the orifice, to make sure it's nice and snug. And we put it across some blocks and we're going to spin it. When we spin it, if it's across some blocks that can't move, this dial indicator would show us how far they've run out. Just in case you're wondering, my record was 17 thousandths of an inch. That's half a wire diameter that was off on an 035 contact tip. Now a little bit about the metallurgy. Our standard class 2 coppers are decent performers, and these contact tips work fantastic. I believe that the really good contact tips, the expensive ones, are a little bit oversold because they're not handling or not controlling your electrode routing. You got some wire scraping going on along the process. I think there's a lot of people that have moved away from class 2 to better zirconium type contact tips just because the other things weren't expected. Make sure that's not you. Don't spend more money than you need to spend on the contact tips in your situation. We also have a chrome zirconium, which is a contact tip that's made to hold up under hot conditions. So when a contact tip has heat conditions, of course, it softens the contact tip, makes the hole wear larger, and starts to develop all kinds of problems from this extra heat. One of the solutions is actually go to a chrome zirconium contact tip that holds up better under temperature and tries to and maintains its position its position in the process. So these contact tips are pretty hard. They hold up to the temperature, and they're very common. Less common are getting into two-part classifications of contact tips. There is a bunch of different versions. The one pictured here is the two-part, and it's actually from a company called Trigascus. Trigascus have these. They're very popular. There's other companies that have these as well. This is my least favorite because it's actually made in two parts, and if you tried with a fair amount of effort, you could knock that center out of there. And I've seen them running with the center actually that's fallen out. But that's one downside of these. But they've been shown to have a fair amount of durability, and usually last much longer than the other ones do. Thank you very much. You could always let me know if you have any questions concerning this presentation or any others.